Hello guys, today we are going to take a look at this little voltage booster circuit. So I was looking on AliExpress for something to take a 1S LiPo up to 5 volts. So that's around about 4.2 volts to 3.7 volts from our battery and boost it up to 5 volts. According to the AliExpress seller, this will boost to 5 volts from 2.2 volts. So easily enough for our battery. And it's also supposedly able to deal with 2 amps of current, which seems an awful lot for such a small little board, considering at 2 amps 5 volts is about 10 watts. So it's pretty, I don't know if it's realistic for this little board, but we're going to give it a try today. If this works, it'd be pretty handy for our models. I've put a header on here, obviously the 2.54mm header, just so that I can wire it up. But without that, the board is pretty tiny, and it would mean that we could very easily get a higher voltage from our 1S LiPo, and even better than that, a stable voltage. So you might have noticed on some of the models, in particular, say the Scania R620, the lights tend to dip when the motors are driving. When the battery's running low, mostly, the lights will dim a little, and that's because the battery voltage is dropping. So maybe this would be able to keep a stable 5 volts, and we wouldn't have any LED flickering, or well, not flickering, just dimming. So what I am going to do today is try and hook this up. I haven't actually tried this yet. I've just made this little wire for it. We have a ground input in the middle, and output on the top is 5 volts. So at the minute I have 5 volts hooked up there. We have our oscilloscope here. We will monitor the output on the oscilloscope. So that is set to 1 volt per division, so 5 boxes brings you up to 5 volts. And I just hook this up. We should have no volts at the minute, so that didn't increase, so that's what we're expecting. We're going to give it 5 volts input to start with, so we should see 5 volts on the output. We have a nice stable 5 volts. So we'll just start to bring the voltage down here. I guess we can just drop a voltage straight away. So down to 4 volts, our 5 volts is still very stable. It actually says here 5.03, so very close to 5 volts. That's at 4 volts. We'll jump straight down to 3 volts. So we're at 3 volts there, and still very stable. At this point, I'll go down in 0.1 of a volt. So 2.9, 2.8, 2.7. Now we're at 2.2, which is, it was stated as the minimum voltage. And we're still getting stable 5 volts. Then at 2 volts even, 1.9, 0.8, there we go, 1.7. So it's actually kicking in about 1.8 volts. Okay, so that's with no load, which is probably not hugely impressive, but you would expect that the chip would work very well, or the circuit would work very well with no load, because, well, there's going to be plenty of power there. What we'll try now is hook up a load. So I thought I'd try and make this realistic. So here is our excavator that we've seen in another video. This takes 4.8 volts from a battery, so 5 volts should be fine. I am going to hook up our supply to the model here. So I've just extended the wires out from the battery terminals, and we're just using this little breakout board, or this little breadboard, to just make our connections. I think I'm actually short 2 wires, so I need 2 more wires to go from this side. connect our ground. And I'll turn it this way so you know on this model there's that sort of a disco light thing that happens. So we'll hook that up here. So we should get our 5-volt output. So now we can see the current being drawn here. At the minute we're only talking 50 milliamps basically. And our power supply, you can see it's starting to judder up there. We are at 3 volts here, but our output is still up at 5. We're at 4.98 it is around about now. If you remember when we had no load it was 5.03, so it was pretty it's pretty close. So let's just try move the boom. Oh, my controller is not working. There we go. So when I try to operate the controller, here's the controller, now watch the oscilloscope. So you can see there's a big drop there. I would say that it's a big drop, but it seems to be repeating. So I think if I change the time per division, if I increase that, so now you can see, well, you could see, it looked like the drop in power well, I was going to say it looked like the drop in power was probably happening every time it was receiving a signal from the receiver, but actually it looks to be doing okay now. So you can see that it's cutting out and restarting, but it seems to be getting away with it at the same time. We're only drawing about 400 milliamps there, maybe. So at about 400 milliamps, it's kind of cutting out. Let's see about the drive motors. I can hear them clicking like they're trying to start, but it just does not have the power. Oh, sorry, I'm the right controller, so let's see. It's not able to do that. You would expect the drive motors are going to be the biggest load, and you can see also the voltage dropping there. So let's up the voltage to closer to, well, let's put it to 4.2 volts. That's a fully charged LiPo battery. So there's 4.2 volts. So you can see that we are getting a drop in the voltage, but it's nowhere near as bad as it was previously. So it's actually, you could probably live with that. Actually, I spoke too soon. It's now starting to cut out. So unless maybe we have a dodgy connection here actually. So when the load is on, it's nowhere near as stable as it is without load, which is what we would have expected. But this is quite an extreme load compared to what we're dealing with. If you keep an eye on the current there, you'll see that it goes quite high. I'd say it's probably going over an amp. Yeah, that went over 2 amps there. So it's actually going at like 1.6 amps at one point I seen over 2 amps. The seller claimed that this was capable of 2 amps. So with this, we are actually on the limits, which is not surprising because the motors that would be in this are those cheap kind of toy motors that you get in all sort of cheap toys. So they're not great. If that was two N20 motors, you would probably be only drawing maybe 600 milliamps. Actually, the load is not so extreme on this that it's probably only maybe 400 milliamps from two well geared motors. You don't want fast N20 motors for that job. You'd want them geared very low so they have lots of torque. So if you spec your motors right, I would imagine this is quite a useful tool. So I'd be quite confident to put that in the Scania, and I think I'll try that just to see how that turns out. We should get the LEDs nice and stable from that, and as long as the voltage stays up. I didn't actually try with a discharged battery, so 4.2 is a fully charged battery. 3.7, let's say 3.6 is a discharged battery. So at this point you're probably starting to do damage to your battery if you're discharging it this low. So a little bit of jitter here. Just one of the cables is probably not great. Let's see if... So you can see that went over, it was at 2.4 amps there. So even at 3.6 volts, it's delivering more current than it actually was stated in the seller's description. So I'm actually quite surprised by that. I think it's getting a little warmer, right? Yeah, there's definitely a bit of heat there, which is not surprising given the currents. Even though we're only doing it in short bursts, it's getting quite warm. And if you were trying to do this continuously, you could expect that that's going to get very hot, especially if you're over the current that it's expecting. But it seems to be doing the job, and given the size, I'd say it would actually fit some of our models pretty good. It might be worth trying to integrate this into one of the PCBs that you plug the control board into, and then you would have a nice stable 5 volts, particularly for something like an excavator. If this was all N20 motors, I would be pretty happy that one of them would be fit to drive it. So that was just a little look at this little booster module. I just thought I'd take you guys along when I tried it the first time. Seems to work pretty good. I think I'd recommend that. Definitely worth giving a go. I wasn't expecting us to get the 5 volts at the 2 amps, but it seems like it's well suited to use with a 1S LiPo. The 3.6 volts, the 4.2 worked very well with this motor, with this load that we were working on. You seen it dropping out, but we were over the specification of this module in terms of current draw when we were talking about these two motors. The use of it with 3.7 volts is probably going to be okay for most applications we are using. So yeah, looks like a pretty useful little board. If you find that useful, don't forget to hit the like button, and as always, thanks very much for watching.